Hello, thank you for joining today's webinar. Today's topic is talking about disaster recovery and cyber recovery. They are not the same thing. This will hopefully clarify that. Many organizations know that disaster recovery is the go-to solution to recover from a cyber attack. That's true, but we know that disaster recovery is missing some features and capabilities that are really required for efficiency and recovery due to ransomware attacks. So we'll spend some time talking about that today. My name is Jim McGann from Index Engines. I will be the presenter. If you do have some questions, there should be a Q&A or a question area on your console that you can type a question in. Feel free to type it in. We're trying to keep this to 30 minutes. So if we don't get to your question today, we will get back to you directly. So what is disaster recovery? Most of you know what this is. It's really a copy of all the data as it gets modified and updated over time. So it's a copy of files and user documents and databases and infrastructure and whatever's required to keep the business running. It's really designed to be very efficient, very large scale, to manage large data environments quickly, typically overnight, to make a replication. The original design capability for disaster recovery was really to support the disasters that include floods, power outages, weather type things. You know, back in the day when it was first designed, cybercriminals weren't even born yet. They didn't even exist. So it really wasn't architected or designed to support those types of events. It's highly focused on instant recovery if you have a downtime to get data back up and running. And it's very connected to the data environment. That's an important point. So highly connected mean that it's in the data center. It's heavily exposed. It's something that is very vulnerable. So it's designed to do what it does, and it does it very well. You know, make sure that data is copied every night and replicated. What it's not is, it's not safe from cyber attacks. We see a number of cyber attacks that occur where they go to the backup media server that runs the disaster recovery replication or backup process, and corrupts it. It destroys the backup environment, destroys the backup catalog, destroys the backup software. We've seen some recent attacks where they can look at the backup environment, understand what backup software is being used, and because they know the backup software, know the vulnerabilities that exist, and go in and be very targeted and very specific. The backup also is not able to validate the data's integrity. That's an important point. So we've also seen attacks that occur where customers' production environment is shut down, and they go to their backups to restore the backups, and they found that they're either corrupted or the data inside the backup is corrupted. So backups is just taking, you know, it's not a massively intelligent process. It just takes data and replicates it. It's not looking at the files and databases and content to say, hey, does this stuff have integrity? You know, it's not looking at files. It doesn't support really selective recovery when you're seeing, you know, specific files or databases being attacked in a cyber attack. You really need to restore the entire backup image. It's not able to diagnose attacks. So if you are attacked, you know, a lot of customers are, you know, left with a bunch of backups that they need to figure out which ones are good, which ones do they go to. Are they quality backups? Are they ones that they should restore? They can't diagnose these attacks in the backup image using forensic reports. So disaster recovery is not cyber recovery. It doesn't have all the capabilities required. So why now? You know, obviously, if you pay attention, you know that cyber attacks are definitely on the increase out there. You know, what we're seeing is that there is a significant volume of activity that's growing. You know, ransomware as a service is probably one of the reasons for that. There is new ransomware as a service vendors. You could call this, you know, toll-free number. They have help desk, they have financing, they share the revenue. You can basically say, hey, I want to attack this company. This is the type of attack I want to do. And this is the type of ransom or the amount of ransom that I want to use. I mean, think about, you know, disgruntled employees. Think about students in schools. Think about, you know, patients that are unhappy with their doctor or their healthcare organization. there's just a wide range of people that when they become unhappy, they could infiltrate organizations with the help of, expertise that exists in this area. And it's easy for them to do. We also see the interesting thing that we've seen over the past year is that attacks used to be going into a data center and encrypting data so it can't be used. They used to leave the data in the data center and not really care about it. Now what we're seeing is that the cyber criminals are going into the data center, and then they're looking around and they're finding sensitive content, and they're taking it outside the data center and holding on to it. So this is an attack at city of Johannesburg, South Africa. There's many of these types of attacks that occur where they're saying, if you don't pay us quickly, we're going to upload the data that we've pulled and make it available to anyone on the internet. So they basically, publish it through like a WikiLeaks type scenario out publicly and, shame the company. So, users and customers have always thought, that their social security number or their credit card number is going to be breached, and they expect that these days. But when it becomes healthcare records and very sensitive stuff that they really don't want the public to know, that becomes a major issue, and it really could cause, a lot of shame and embarrassment, but also, a lot of customers losing faith in these companies and working with these companies if their data can't be trusted. So ransomwares are turning into a data breach, and the fact that the cyber criminals have this data, this sensitive data, the fines that they're asking for are increasing significantly. They used to be, $5,000, $10,000 fines. Now they're hundreds of thousands, even millions of dollars fines because they have this sensitive data. And finally, the attacks are becoming more sophisticated. This was an attack that happened about 2 or 3 weeks ago on Epic Global, which is a governance company, e-discovery and governance company that provides legal services. So the attack here, what's interesting about this is they initially used what they call a trick bot Trojan to go infiltrate the data center, mine passwords, kind of rummage around inside the data center, look and see what's set up and what environment exists, and then find the easiest way to kind of to corrupt and the most effective way to corrupt the data. And after the trick bot did its job, after about 2 months, they sent the Rook ransomware in, which is basically a standard encryption algorithm to encrypt the data. So they did a two-pronged approach, and the cyber criminal, was hands-on during the whole process. So they were looking and analyzing and using their knowledge to impact the most damage on this organization. So a lot of stuff changing over the past year. So backup. So getting back to backup, can it evolve to cyber protection? It needs new capabilities. As I mentioned, there's some of the key areas where cyber protection needs new capabilities built into the backup environment. It needs modified deployment. I guess the issue I spoke about earlier about being exposed out in the production environment is an issue that cyber criminals can easily, take advantage of. And it needs automated workflows. Anybody that we talk to in the security field or the cyber field, they want automation. They don't want to have to manually check things and manually, be part of the process. They want it automated, like a red light scenario. Red light, we've got a problem here. That's what they're used to. So, for data protection, there's really a layered approach here. And, on the yellow, the outside edge there is your traditional data protection best practices, layered data protection, constantly looking at new data and layering on backups and protection of the data to make sure that it's secure, for a disaster. Protects all data assets. It looks at the entire enterprise's data and protects all that content. Going deeper in here in terms of getting into more of a cybersecurity capability or layering cybersecurity on top of data protection, you need to add additional hardening and protection features. So harden the data, encryption in flight to make sure that it's, as it's being transmitted to its protection environment, that it can't be, sniffed or accessed. And retention lock. Retention lock is really once it's copied and replicated and protected, to lock it down. So locking it down so you provide very separate credentials to get access to it. So a lot of the backups don't have retention lock, and cyber criminals are going in and modifying or corrupting the backup with something like a retention lock. it's locked away, so no one can touch it and no one can modify it except those specific folks that have those credentials. And going even deeper down in the center of the core, the green area, is advanced protection services. This is where you start getting the features that are really related to cyber security. So adding a layer on top of data protection that includes things like isolation, so isolating the data. Isolation is making it not even visible to the cyber criminals, so they don't even know that it exists. If they come in and execute an attack and they're attacking data in production and not even knowing that a good copy of it exists in an isolated environment, you're really hiding it from them. It's equivalent of taking your family valuables and putting them in a safety deposit box in a vault. Integrating analytics and machine learning to really look at how data changes over time. Automating the detection of a cyber attack. Forensic reporting to figure out what's going on. All those features when we go into detail on are critical. And when you look at the sphere over there and you kind of get into the inner core, it's a difference between good, better, and best. Good is, your outside, traditional data protection. That's what every organization has today. It's good. If you're going to stand in front of your, company executives or your board of directors or your company and say, we have backup, it's good. We think we could be okay. That's not the confidence you need today. You need something that's not only good, you need better and best. You need to say, we have the best protection right now for an attack, and we feel confident that if we do get attacked, we will be okay. So again, different layers going, from just existing approaches to data protection all the way deep into the core to cyber protection. So one of the solutions that I'm going to talk about today is a hardware software solution available from Dell EMC, which includes our CyberSense software. So CyberSense is a software component from the index engines. This is the company that I represent, and is partnered with Dell EMC to provide the state-of-the-art solution here, really compared to what's on the market today. And you look at good, better, best. This ticks all the boxes in terms of the best solution in terms of an isolated data protection / cyber protection environment that is really robust and is being deployed at hundreds and hundreds of sites globally today. So the key design criteria, going back to what I spoke on earlier, is really isolating and secure. So isolation is an approach that, that is becoming more and more standard. So air gapping this data off the network. Again, it's taking your, the family jewels or the crown jewel data that you have in your organization. And this could include, infrastructure data to get your networks back up and running, Active Directory, LDAP, things like that that are required to get your network up and running, all the way to critical user documents and databases. So air gapping them off the network. Air gapping means that there's no physical connection or no wired connection or no connection at all to the network, and making it invisible to cyber criminals. So nobody even knows it's there. The idea is that if you create this isolated environment and you put your critical data saying that I need this stuff to bring my business back up and running if everything gets wiped out, and putting it inside that vault and locking it away and making sure it's invisible. That's the only way that you're going to protect. Unfortunately, the way we are today, cyber criminals are in the data center. There's no way around it. I mean, the real-time security solutions and the protection solutions that exist out there aren't 100% effective, and they are penetrating the data center. They're getting in. They're sitting inside there. I mean, dwell time is long. Dwell time is a time when they kind of go inside the data center and they rummage around and see what's there. It could be months without anybody even knowing. So the fact that there's an isolated environment is critical. Immutable storage, the fact that it's locked down, so nobody can touch it. It's secure from cyber corruption. Even if they got in there and they found that copy of that backup data in there, the secure stuff that's in the isolated vault, it's immutable. They can't modify it. They can't encrypt it. They can't corrupt it. They can't delete it. They can't do anything to it. It's locked down. It's military spec grade, lockdown capability. And then the third component is integrated data audit. So the question people ask is like, yeah, I'm putting my critical data assets inside an isolated vault. How do I know it's good? How do I know it isn't already corrupted? How do I know they already haven't come in and done some damage here? How do I know that an inside actor, an inside, cyber, someone that's going to really execute damage, a current employee that's not, out there doing some damage on the data, hasn't already done so. So data audits is looking at corruption due to attacks. It's looking for things like encryption and looking for mass deletions. It's looking for data corruption where they're corrupting contents of files. And comparing point in time, looking at how the data changes. It's a very intelligent approach to auditing the data to say, hey, it has integrity. So if your organization does get attacked and you go into this isolated vault to get this copy of this data and say, hey, I need to recover, you have the confidence knowing that that data is good, and that if you need to recover, that you can recover with confidence without having to check it first before you get it back in the primary production network to get the business up and running. And then finally, a bunch of forensic tools and reports to be able to figure out what happened. So a lot of companies struggle with this. When they do get attacked, they don't know the who, what, where, and when are they attacked. You know, what files were attacked, who did it, where was it done, when was it done, and where's the last good copy of the file. So all critical questions that need to be answered in order to really facilitate and accelerate the recovery process. So that's what cyber recovery needs to be. If you check the boxes of your current disaster recovery environment, it's missing a lot of those components. So that's really the difference between the two. So I mentioned Dell EMC. We are partnered with them with this solution, which is an isolated cyber recovery vault. I'm going to get my capability to draw here. Yeah, so in your production network, which everybody has obviously here, okay, I'm just drawing a line. What there is a cyber recovery vault is a new isolated vault that's built. It could be on-prem, it could be in the cloud. There's lots of different scenarios here. I'm not going to get into the full details of this. You know, there's lots of different presentations that could cover this. So what that is the ability to, you know, replicate data. So there's a sync that happens here. Okay, and my drawing is not very good today. Sync that happens here, that's air gap. So this sync happens, when the sync happens, there's a connection that's made. It's a dedicated port that's not published. It's a very hidden port that's opened up for a very short period of time to replicate an incremental update into the vault. And then at that point inside the vault, there'll be a copy lock. That's a retention lock where the data is locked down. At that point, then the vault is air gapped, so it's cut off the network, doesn't even connect to the network anymore. And at that point, the CyberSense product, which is really what I'm going to spend more time on today, will go in and do analytics on the data to say, hey, the current data that you pushed into the vault and replicated the vault, I need to do analytics to give you the thumbs up that the integrity is there. So it's a simple process, simple architecture that really gives customers confidence that what's in that vault is isolated, it's secure. Analytics have been run to know that it has integrity. And if my production network there on the left has some kind of attack and everything gets wiped out, I can go into my vault and I can pull out core infrastructure, Active Directory, for example, LDAP. I can pull out data, I can pull out databases and content that have been analyzed quickly because I don't need to check them because CyberSense has already automated that process. Okay. I need to clear my annotations and then move on. Okay. So one of the key features of CyberSense, of the analytics, which we're going to spend a little time talking about today, is the ability to directly index these backup images. So customers are using all these common backup software to back up data into the vault from Dell EMC, Veritas, IBM, Commvault. Those are proprietary backup images that are really containers that contain the data inside those images. So CyberSense has the ability to go inside those backup images without using the original backup software and to index the content that's in those backup images. Full content indexing to look inside them, look inside every file, every database to check to see if the integrity is good. So the workflow is pretty straightforward. So with the vault, a scan occurs. So as the data is replicated into the vault, so that process is fully automated. It happens every night. So an incremental update of all the key data assets that are required to be replicated to the vault. This is your, the critical, crown jewel data. As that scan occurs, as that replication occurs, the data is scanned with CyberSense to create analytics on the data. So it analyzes and looks inside every file, every database to check it. Think about that scan as an observation. So observation and scan It wants to do an observation as data changes over time. So every time data is replicated to the vault, a scan occurs. That's a point in time observation. It'll compare it to the previous observation and say, hey, this was a PDF. Let me see how this changed from the previous observation of the PDF. So it's looking at how data changes over time, an important feature here. Over 100 analytics are generated. These are analytics that are indicative of a cyber attack. So we use one of the most important analytics that's generated is entropy. Entropy is the random disorderness of a file or a page of a database. So entropy score is defined from 0 to 100. So for example, as that PDF gets replicated in the vault on Wednesday and has an entropy score of 47, Thursday it's 47, Friday it's 99. 99 indicates encryption. So that PDF was encrypted somehow. It could be encrypted by a user or encrypted by a cyber attack. Other analytics are generated include file extension mismatch. So by reading the header of that PDF, for example, the header would tell you, hey, this is the structure of the document. Is the structure right? Is the extension right? Is it a PDF extension? No, that extension changed to .lol or .encrypted. So with a high entropy score on that PDF and an extension changed to .lol or .encrypted, that's an attack vector. So these statistics that include file corruption, mass deletion, mass creation, all sorts of different statistics, over 100, are fed to machine learning that's been trained on all the common malware and Trojans and ransomware that exist. So when it sees that PDF becoming encrypted and the extension being changed to .lol, it says, hey, I know that's an attack vector. So that's when it sends an alert. If every time data is replicated or a new observation occurs into the vault, and there's nothing that looks suspicious, then you'll get basically a green light saying, hey, everything looks okay. So if everything looks okay, that'll scan, that process repeats over and over and over again. And you have the confidence that that's what's isolated and protected in that vault is secure and good and has quality and integrity. And if you do get attacked, can be restored. If CyberSense does see some sign of red alert and saying, hey, it looks like you're under attack and there's some data corruption going on, there's a number of forensic reporting capabilities to figure out what's happening. So, you know, a red alert scenario is critical for a company, but with these forensic reports, you can really understand very quickly what's happening. And I'll talk about those. So tech specs, I talk about the data types that CyberSense does support and what customers are typically putting into this cyber recovery vault is unstructured files, key documents, intellectual property agreements, databases, Oracle DB2, SQL, Epic Cache if you're a healthcare organization, and a lot putting in core infrastructure, you know, DNS, LDAP, Active Directory to be able to rebuild networks because cyber criminals do attack this core infrastructure and shut down businesses, networks that way. Backup software, as I said, directly index backup software. I mentioned the different types of backup software that's supported. Again, without the need to rehydrate the backup image or the data out of the backup image, CyberSense can perform analytics. And CyberSense runs on a series of servers. It really depends on how much data you're doing analytics on. We have customers that are doing 10 terabytes. We have customers that are doing petabytes of analytics on data. Okay, so to understand CyberSense and what it's doing, you have to understand the different types of attacks that occur. So CyberSense is full content-based analytics. There are a number of other solutions out there that provide metadata level analytics, and I think it's important to understand the difference because the metadata only approach is not going to give you the confidence and the reliability that you need to really you know, understand when the attacks occur. So if you look at the types of attacks that typically happen, on the left there, you'll see kind of the high level structure of a document. This could be a PDF or it could even be a database, for example. So there's file metadata at the highest level. So we all know that, the extension. So .pdf, for example, the file size, the file location. So there's types of attacks that you could add a known ransomware extension. So typically on a file, they would append the .pdf, they would append on that another like .encrypted or .lol or .loki or .crypto. So they would modify the extension. A change in file size. So maybe when they strip out content of a Word document, the file size dramatically changes or decreases. So those are metadata-based analytics that you can see high-level view into what happened to the data. Fairly easy to detect. Harder to detect is the document header, looking inside the document header. So some of the cyber criminals are smart enough to know that, hey, I'm gonna change, and that's where you can see the true file type or the true structure of a document. So the document header of a PDF would say, hey, this is a PDF. It should have a PDF extension, and it should have a structure that's typical of a PDF. That's in the document header inside the file. So changing the file extension to something like .fun, which is a valid extension, which they often use, a lot of the metadata only tools would look at that and say, hey, .fun is a valid extension, so that's good. But by looking at the header, you would say, hey, this is a PDF, why does it have a .fun extension? So you would look at, by seeing the header, you would know that. Or looking at the corrupted file structure. So looking at an Excel spreadsheet and saying, hey, does this have the structure of an Excel spreadsheet? Hey, there's some embedded content in here. No, that doesn't make sense. And then deeper down, looking at types of attack that are based on content. So encrypting inside a file or a page of a database. So encrypting a page of a database is deep type of attack, or corrupting the content. So if you're using metadata only tools, you're really going to see just the high level types of attacks. CyberSense uses full content analytics, which is 99.5% effective, looking much deeper than just the metadata, going into the deep content-based types of attacks. So a high-level view of how content-based analytics are critical here, because right now with metadata only, you're looking at about 88%. Unless the cybercriminals start seeing that you're discovering them and discovering those easy attacks, they're going to go down deeper to the more content-based type corruption, and your 88% is going to quickly drop significantly. So the forensic analysis, let me move through this fairly quickly. So if you do get attacked, what type of analysis and reporting do you have to diagnose and recover? So with CyberSense, you can know when it happens. So the idea is you're replicating data and copying and backing up data. CyberSense will look at that as an observation and say, hey, this new observation looks like something's wrong here. So you'll know when it happens. You'll not have to just be, have blind faith in your backups to say, hey, I hope they're good. Hope is not a strategy here. So it'll tell you when it happens. Number two, it'll tell you the investigation, the who, what, where, and when did it happen. And I'll talk more detail about that. So all the details to figure out and intelligently figure out what is actually happening in order to really minimize downtime and take, the recovery process down, down from weeks and months to hours and short days. So the output of CyberSense, and this gets, deep pretty quickly, is that the idea is that you need to recover, and it's like, I need to know what backups to put up and recover from. Where's my last good backups? So CyberSense is continually auditing the data. So on the upper left, you can see a report that can be run with CyberSense saying, show me the last good version of the file. So CyberSense auto tags the corrupt files as they get corrupt. So you automatically know which files were corrupted. And it also tags the last good version of the file because it has observations. It has point in time observations. So it says, hey, this file became corrupt. I'm going to tag the last good version for you. So as you search and say, show me the last good version of all the files that were corrupt, you'll see there on the right side highlighted in red is the few thousand files that were corrupted. Basically, you can ask CyberSense, what backup sets do they exist on? Because CyberSense captures the backup metadata. And you can do a summary report, an automated report that says, hey, the last good versions of these files are located on these backups from these dates and these backup set IDs. That's what you need to restore. And what you need to do is basically restore those back into production. And when you do that, then the corrupted data is off your primary storage environment and your business is not impacted. Very quick, very easy. So how do we get here? Like I said, CyberSense creates a comprehensive index of your data, how it changes over time. We talked about that. Over 100 security analytics. We talked about that. And then machine learning that's trained on thousands of Trojans and over 20 attack vectors. Again, we talked about that. So when data corruption occurs, what CyberSense kicks out is the attack vector notification. So it'll tell you what attack is being executed on your data. It'll kick out the full listing of files and the full file path, file name that have been corrupted. So if it's 5 files that are corrupted, hey, this is an attack, but it's very small. If it's hundreds of thousands of files that are corrupted, it's like, hey, we've got a problem here. We need to address it very quickly. If they're all located on the same server by chance, let's get that server out of production. So it gives you detailed and reports to be able to figure out what happened. You can also get a report on the breached user account. So cyber attacks are being executed through user accounts, some user that clicked on a phishing email. So it'll tell you that user account, John Doe, is the one that's being used to execute. And it'll tell you the executable that's being used. So if 10,000 files were encrypted, it'll tell you this is the executable that's being used to encrypt those files. That's your malware or your ransomware. And then finally, it'll tell you the last good copy, as I showed you on the previous slide, the last good copy of files and what backup sets they exist in. So this is the dashboard with the Dell EMC Cyber Recovery product. CyberSense is built into this solution. So you can see in the dashboard, the alert will be displayed in the dashboard. So that's all you need to see is on this dashboard, hey, we have an alert, we have a problem here. So it looks like data is being corrupted. That's all you need to see. You can get a detailed list of the analytics. You don't need to do this, but you can see all the detailed analytics that exist. I mentioned there's over 100 of them. Looking at entropy score, as I mentioned, file deletions, file corruption, file extension change, all sorts of stuff. What you do need to see is the attack vector. So basically it's saying, hey, based on the way the data is changing here, it looks like you're under attack vector number 6. So CyberSense monitors about 28 different types of attack vectors. A lot of them are very obscure. The top 6 highlighted in red there are the most dominant ones. Those are 99+% of what cybercriminals are doing today. So the previous slide said it was attack vector 6. That's a very common one, encrypting a file and changing the file extension. So changing a Word doc by encrypting it and changing the extension to .encrypted or .lol. You can run reports of detailed file listing. This is showing a report of the corrupt file versus the last good version. So it's comparing the files. If you see the Word icon next to the 0001.doc, that's the last good version of that file. The one above it is the corrupted version of the file. And you can see here what they did is they appended the .fun extension onto the document, and they corrupted it so that CyberSense can't even read the file. The question mark there, it doesn't even know if it's a Word document anymore. It's been corrupted so much. You can run a whole series of reports to look at the corrupt files per server, look at corrupt files by extension. So you see a bunch of .lol, .encrypted files, corrupt files by user SID. This is not an environment connected to Active Directory, so it's not going to resolve those SIDs, but you can see which user files are being corrupted. Lots of different reports that are being generated. And you can look at detailed metadata on each file. So now that same file I mentioned earlier, the 002.doc.fun, that's a corrupted file. The file type is now unknown. File entropy is now 99, so that means it's also encrypted. So that file has been attacked by ransomware. So you can get all sorts of detail on this. But what you really want is this listing. This is really what your IT organization, your backup administrators, your team that runs backup needs to say, hey, it looks like we were attacked. There's a couple thousand files that were corrupted. They're highlighted in red. Let's not get into the detail of it. Just get these backup sets from these days, because as the corruption happens over time, it's going to be over a series of different backup sets over a series of different days. This answers their question is like, where are my good backups? So what they would have to do now is create a clean room environment and manually restore the backups and check the data and check the data quality and see if it's okay and not corrupt. This automates that process and says, CyberSense has checked this. CyberSense knows these are the good files that need to be restored. And these are the ones that you need to put back in production, and your business will avoid any interruption. I kind of sped up towards the end because I'm 5 minutes over the time that I was told to finish this up. So I apologize for that, but I hope you found it interesting. I'm not going to have time for questions today. If you do have questions, feel free to reach out to us. Our website is indexengines.com. We have a couple of white papers and more detailed information on CyberSense, as well as the Dell EMC Cyber Recovery solution. If you have specific questions and want more information, feel free to shoot an email to us at info@indexengines, and we will get back to you right away. Again, sorry for the overage here, but I hope you found it interesting and look forward to any of your feedback and connecting with you in the future. Thanks for your time today, and enjoy the rest of the day.